Hello, and thanks for joining us. In this video, we're going to be looking at using Cramer's rule to solve a simultaneous system of equations that has complex coefficients. And this problem happens to come from the IB Analysis and Approaches higher level textbook from Oxford University Press, but for which there are some errors in the typed solutions in the textbook. So I thought I'd provide a explanation of what's happening. So, general solution approach for systems of linear equations was developed by the French mathematician Gabriel Cramer, and the solution approach is called Cramer's rule. So if we have an augmented matrix representing a linear system, the solution of the system can be given by the following, right? Where x is going to be equal to this, y is going to be equal to this, where the denominator, d, is the determinant of the matrix of coefficients, right? So the matrix of coefficients from the system, that's going to be our denominator. And you compute it in a kind of butterfly pattern. You'll say a times d minus b times c, right? And then this d subscript x will have a determinant that it represents, and d subscript y a determinant that it represents. And the way we get d subscript x is we're going to swap the column of the x variable with the column of the constants, right? So we'll swap AC for EF and compute the determinant E times D minus B times F. And for y, the numerator here, we'll swap the y column. So we'll swap b times d, or the column b and d with ef. So we'll have this determinant, we'll say a times f minus e times c. All right, so let's see how we use this to solve Cramer's rule. All right, so once again, the first thing that we have to do is to compute our denominator, our main determinant, right? So that main determinant is going to be given by the determinant of the matrix of coefficients. So I have 3 and 1 minus I representing my coefficients of x, and I have 2i and negative 1 representing my coefficients of y. All right, so 3 times negative 1 is going to be my first part, and then I'm going to subtract 2i times 1 minus I. And so if I go ahead and distribute, that's going to give me a negative 3 minus 2, let's see here, minus 2i squared. So we know that 2i squared is negative 1, so this would be like saying plus 2. But then I need to distribute the negative to both terms. And so if I distribute this negative to both terms, that's going to give me negative 3 minus 2, which is going to be negative 5, and actually that should have an I there. So negative 3 minus this 2, right, because that's going to be a positive 2, so that's negative 5, and then minus 2i. All right, so be careful with your organization. Then my column swap for my next determinant, I'm going to take the 5 plus 7i and the I, and I'm going to swap in to my matrix. So I'm going to have 5 plus 7i and I for the first column, and I'm going to keep the 2i and the negative 1 for the second column. So that's going to give me negative 1 times 5 plus 7i. So that's going to be negative 5 minus 7i. And then I'm going to subtract 2i times I, which is negative 2i squared, which is like positive 2. All right, so I have negative 5 plus 2, so that's going to be negative 3. And then I have negative 7i, so negative 3 minus 7i. Then my determinant after swapping my y column, right, then my x column is going to stay as 3 and 1 minus I, and my y column now is going to become 5 plus 7i and I. And if I compute that determinant, I have 3 times I, which is going to be 3i. Let's make this I a little bit neater. And then I'm going to have minus 5 plus 7i multiplied by 1 minus I. So let's go ahead and make that computation. So I'm going to have 3i, and then make sure I pay attention to my negative. Right, and so I will have, in distributing, 5 times 1, that's 5. 5 times negative I, that's negative 5i. Make the I a little bit more clear. 7i times 1, that's going to be plus 7i, and 7i minus I, or 7i times negative I, that's going to be negative 7i squared. Right, and let's go ahead and look at these two together. That's going to be a positive 2i. We know that this is going to end up being a plus 7, and that's going to be a plus 5. So I'm going to have 3 minus 2i, which is I, and then I'm going to have 5 plus 7 is 12, but times the negative, then I'm going to have I minus 12. So I have all the things I need to compute my solution now. I know that my x solution is going to be given by the determinant with that column swapped x, negative 3 minus 7i, divided by my main determinant, negative 5 minus 2i. And my y solution, let's give us a little bit of space. My y solution is going to be the determinant, negative 12 plus I, all over my main determinant, that's negative 5 plus 2i. Oh, not plus 2i, negative 5 minus 2i. All right, and so we'll know that we need to multiply. If we don't have a calculator, let's multiply numerator and denominator by the conjugate of the denominator, so negative 5 plus 2i, all over negative 5 plus 2i. And the same thing over here. Let's put our parentheses so it's clear. Negative 5 plus 2i all over negative 5 plus 2i. All right, clear on our parentheses. So with that multiplication, if I look at my denominator will be the sum of the two squares, so 25 plus 4, so this denominator will be 29. And the same thing over here. I know my denominator will be 29. Negative 3 times negative 5. If I distribute on the x numerator, that's going to be positive 15 minus 6i. Then I have, let's see here, plus 35i. And I have minus 14i squared, so that's going to be plus 14. Okay, and in the y direction, negative 12 times negative 5, that's 60 minus 24i. Then I'm going to have minus 5i, and finally plus 2i squared, so that's going to be minus 2. So my final solution, right, my final solution will be that x is going to be equal to, let's see here, 15 plus 14, that's 29. 35 minus 6, that's 29, so that's going to be 1 plus I. And my y solution, I have 60 minus 2, that's 58, divided by 29, that's 2. Negative 24 minus 5, that's negative 29, so minus I. So then that'll be my final solution. X is 1 plus I, so complex solutions for these complex coefficients. What's nice, if we want to check our answers, our NumWorks calculator will do this work very nicely. So I have, right, 3x plus 2 times I times y, right, shift equals 5 plus 7i. So there's my first equation. And then my second equation, let's see, parentheses 1 minus I, close that parentheses, times my variable x, and then minus my variable y, and that will be set equal to I. And let's go ahead and solve the system. And we see that x is 1 plus I, y is 2 minus I. So solving our system of equation, complex coefficients using Cramer's rule. Thank you for your time.